Hi everybody. So, are you ready to do your lab calculations? Make sure you open up your lab, get your calculator out, and here we go. So, this is my sample data. So, it is just, ooh, I didn't mean to do that. It is just an example. So, your data is going to be different than mine. So, make sure you have your numbers written down here. All right, so this is a sample data. So the mass of my water is the amount that I put in my graduated cylinder. So it says mass, but really the mass of your water is just the volume that you put in your graduated cylinder. The initial temperature is the initial temperature of the cold water. So 15 degrees Celsius, it's very cold. The final temperature, notice how these two numbers are the same. The final temperature was the final temperature of the metal and the water in the same cup, okay? Same number here. Now my change in temperature, I do my final minus my initial, okay? So for here, it's 12 degrees because it's 27 minus 15. And this one is actually a negative number because I'm cooling down my metal. So 27 minus 95 is negative 68. Anytime you are cooling something, your temperature change is going to be negative. So for my calculations, what I need to do for my water is figure out what my amount of heat gained by my water was. So I'm going to take the mass of my water, which was 100. The specific heat of water for everybody is going to be 4.18 because 4.18 joules per gram degree Celsius is the specific heat of water. So everybody should have this number. This number right here can be different, okay? What amount of water did you use? How many milliliters? That is what's going to go right here. And here is your change of temperature for the water. So if you need to go back, pause this, and write down your numbers, go ahead. You can pause this and then write down your numbers here. Once you have everything written down, you're going to multiply these things together. The mass of your water, the specific heat of the water, and your change of temperature for the water. That's going to give you a number. For my sample data, it's 5,016 joules. When you get your number, write it, put it in a big box, because that's a very important step. Now the really cool thing is that the amount of heat gained by your water is the same number as the amount lost by your metal. But since our metal is cooling down, the number is going to be negative. Anytime we cool something down, it's always going to give us a negative Q value. If we are losing heat, it gives us a negative value because we have a negative temperature change. Okay, so we're going to use this Q value in our calculations. So whatever you got here for your Q, okay, keep that in mind. All right, so now we have to figure out what our specific heat of the metal is. So all these numbers are going to be the numbers for your metal. So the heat that is being lost by my metal, okay, I got negative 5,016 joules. The mass of the metal that I used in my sample data was 127.1 grams. Remember, this is the mass of the metal, not the water, but the metal. Okay, so put the mass of your metal here. Here is the temperature change of my metal. So go look in your data, the temperature change of your metal. This should be a very large number, a negative number, okay? When you type this into your calculator, make sure that you have all of these guys, the bottom numbers here, make sure that you have these in parentheses. You might want to multiply these two numbers together first, so that way you're doing your order of operations correct. So I could do 5,016 divided by this entire quantity, 127.1 times negative 68. So what I could do to make sure that I'm calculating it correctly, is do this in steps. I could do 127.1 times negative 68, and that gives me this quantity right here is negative 8,642.8. And then I can do negative 5,016 divided by negative 8,642.8, and that gives me 0.58. So if you need to do that in 2 steps, do this in 2 steps to make sure you're getting the correct number for C. It should be something less than 1, and it definitely should be a decimal. So if you're getting a really large number that's not less than 1, make sure you're using the right mass, the right change of temperature, and that you have it set up correctly in your calculator. Okay? The next step is really important. You need to look at what you got for your C, your specific heat, and you need to compare it to the chart that you have. Okay? You've got a chart that has all the specific heats. This chart is in Schoology, and you also can have a paper copy if you choose to print it out. So the one that I got is 0.58. That is closest to 0.5. So I'm going to say that that must be steel because 0.58 is closest to 0.5. So since my calculations show that, I'm going to go with that. Alright, so now what I'm going to do is my percent difference. If you go to the page in your lab that is after your calculations, this is the formula for calculating the percent difference. So I'm going to take my experimental value, which for me I got 0.58, and these bars mean absolute value, not 1, minus the actual value, which I found in the table, which was 0.5, and I'm going to do that over my actual value, which is 0.5. And then since it's percent, I'm multiplying this by 100. So when I put that in my calculator, I get 16%. Okay, so my percent difference from the actual amount is 16%. So now for my error analysis, I have to think why. Why am I getting something that is 16% off? And if your number is even higher than 16%, you need to think, why am I losing so much heat? Where is it going? And think about things like when you buy hot coffee or hot chocolate, how is the cup made to minimize heat loss? And why didn't we do that in the lab? Okay, so think about how our experiment was set up and how heat could have been lost to the surroundings compared to in real life when you get hot liquids. How are those cups made to keep the heat in your cup? Okay, those are some things you can think about in your error analysis. All right, so what you have in Schoology is the specific heat metal rubric, and I've also printed out a copy for you. So when you're writing your conclusion, you're going to make sure that you include everything on the rubric. The conclusion is on the second page, so it's got a checklist of everything that you need to include in your conclusion. And on the first page, it's got everything that you need to include going up through that. For example, in your background knowledge, make sure that you look at these readings for your background knowledge. Okay? Your background should be a paragraph. You want to think of things like, what is specific heat? What's the definition? Okay? You want to know, tell me what the formula is. What do all those variables stand for? Okay? All that stuff can be found in the reading. The more detailed your lab report is, obviously the better you're going to do. Okay? So make sure that you're using these resources. Use the rubric, follow each one of those steps for your conclusion, and look at the readings that are in here. Your lab has a due date of Thursday for the purple day, Friday for the gold day. So make sure that you're getting all your work done in class today, okay, and that you submit it to the assignment on Schoology. And then that's it. If you have any questions, of course, please rewatch this amazing video and email me if you have anything else. All right, thank you. Bye.